Welcome again. We'll keep on talking about housing now. Industrialized public housing in the second panel for the FAR 2022, but in this case, from a different perspective. Industrialized modular public housing, specifically through our close-by projects, and Barcelona has a few examples of that, and we'll do that through a series of studies that have put this into practice in their projects. In charge of presenting this panel with Cecília Colomer, architect in the Municipal Institute of Architecture of Housing in the City Council of Barcelona, and among other participants, we'll get to know the work of Marc Obradó from ENG Arquitectura, Yaiza Terreno from Yaiza Terreno Arquitectura, and Lluís Roig from Tribuna Arquitectura. You can come onto the stage. A big round of applause for them, please. Good morning, everyone. Restarting now after the coffee break. I left my coat on just in case. First of all, I would like to thank the organization of this conference for having given us the opportunity to present the projects that we're working on and to present the work that the City Council of Barcelona is doing. Irene Subils was meant to come from the City Council as well, but she wasn't able to make it because this morning she was last minute. She had a last-minute problem. She was going to introduce the subject from a more institutional perspective, but we have architects that will be able to explain the project from an architectural point of view. So we will now start introducing this presentation on modular industrialized public housing. What architects have explained for examples of wood structure projects, and we've seen that wood is answering very well to the premise of minimizing environmental health in association of certain materials, and it is also good in terms of reduction of execution and generating a high-quality architecture. And we have also been able to see that in the bidding processes and the writing of projects together with the work as a mechanism to bring the application of industrialization process forward for the housings has been an efficient mechanism in order to generate a broader array of solutions which in different ways have been given answer to the goals that we had been setting ourselves. So what you can see on this chart are the different solutions that were offered for the bidding to the solutions, and 6 or 7 suggested that were presented, of which 6 have been accepted environmentally, of which 4 were solutions in three-dimensional models, such as La Casa por el Tejado, which means literally starting the house by the roof. Another one through a three-dimensional system for jet housing. We can also see the different impact values for each one compared to average of three-dimensional solutions and with the average of all solutions, including the other ones we've seen. And we also have the dispersion diagram of three-dimensional solutions, where we have marked the position of the Morocco project that we'll be explaining with their impact value. We can see the different solutions. The maritime containers in the first place, models containing from an industrial structure that was used as a structure as a part of the closing, with the different necessary adequations, and differently to others, this is an open system and a universal system, which allows as not to be linked to one only provider. In the second case, we have three-dimensional modules that were presented by Compacabit and La Casa por el Tejado. They were a metallic structure with a concrete frame or with a coolant frame. And the third system that was proposed was a JIT housing system, which was steel tubulars and thermochip panels that were made up by fibrous concrete isolation panels and also plaster fiber panels. Maritime containers, shipping containers, are falling within this category of three-dimensional materials, but they have been grouped in the same table. What characteristics do these three-dimensional solutions have, by opposition or differently to the solutions we've seen before? Comparing this system, what we see is that the industrialization here is taken a bit further beyond the 2D systems, because this system is a complete system where the provider is the same. It does the providing and it does the assembling as well. The fact that most of the tasks are carried out in the workshop means, on the one hand, a greater control of product quality, and on the other hand, it allows the environment to be under control so that working conditions are allowing for other sectors to be incorporated in the world of construction, sectors which would have otherwise not have participated probably. And on the other hand, it allows a cost reduction, significant cost reduction. The fact that the planning is optimized means also there's an overlapping of the work in the workshop and the work on the site. The construction of three-dimensional models are starting in the workshop and before it starts, with the foundations we're starting with the foundations on the site. Therefore, these solutions are comparatively bringing higher quality solutions compared to wooden solutions. However, they still mean lower values compared to conventional construction systems, traditional constructions, so to call them, at least in the chapters that have been analyzed in terms of facade and structure. Another interesting aspect here is the integration of the agents. All of these are aspects that are cross-cutting and common to all industrialized solutions. We're not saying that some of them have them and some of them don't, but some solutions have them in a better way than others. We have done 2D wooden chart, a wooden chart, and the three-dimensional solution chart. But in reality, there is no such thing as a division between the two, because, as we have seen, Isabel Perez was explaining her project with 2D wooden solutions for the construction of barracks. And there is a combination of both in different degrees of using these different systems. Regarding collaboration, in these three-dimensional systems, the management system for project and works itself demands a close collaboration between the site workers and the building companies, but in tridimensional projects, this is even more so, because the technician, the architect, will need to have the knowledge from the worker in charge of the system. So there is a collaboration at all levels of the project, not just at the levels of a structure, but also the finishings, facade, equipment. And this collaboration will allow a different way of working. There's a change of paradigm here. From the very start of the project, all contracting is being anticipated so that when the work will start, everything will be hired already beforehand. And this is why we're showing this image of the tailor-made suit, because there's this close collaboration between the constructive system and the expert who's carrying out the project, the industrialist working with these tools. Finally, in the case of shipping containers, this is a different case because this is a universal open system and it doesn't relate to just one provider. Therefore, if the provider changes here, the system doesn't need to change necessarily. As a final assessment for this, and relating this assessment to the former panel and what Daniel was saying about the biddings, the assessment has been highly positive, as you can imagine. What we have seen is that the fact of incorporating these industrialized techniques in the world of housing, and most of all, the fact of understanding that this involves a different way of working with a collaborative strategy that we have explained. These two different things have allowed us to attain the goals that we had. Reduction of environmental impact associated to the fabrication of materials, the reduction of deadlines, and finally, generating a high-quality architecture. And a point to be improved here has been that the architectonic proposal is highly linked to the construction company. So we're working on it with the experience of these first 6 projects, with all the values that we've obtained. We've been analyzing all this data, reflecting on all these projects and the relationship between the obtained data. A threshold of environmental impact should be established in terms of a maximum standard under which the projects should be presented. Since we've got this big array of solutions and parameters, and we already received them, now we need to establish a parameter starting from which all solutions can derive. We also need to keep on promoting industrialization as a very efficient way to reduce deadlines or delivery terms or delivery periods, and finally to launch a bid for a reduction of project and also a bidding for the work with a pre-project, separating the two figures, maintaining the overlapping that will allow the collaboration strategy, which we think is highly important and necessary in order to keep on advancing in terms of our goals, our set goals. And this was my our presentation, and I will now give way to the projects that our writers will explain. And first one is 45 protected housing in Marc 880 Street with three-dimensional module solution. One of the architects, Marc, and designer of the project, Marc Obradó, will explain it. He is an associate member and founder of Arquitectura, and they won the IMAP prize together with Compacabit and Cardonet the construction companies. Marc has been working for over 30 years with 2D, 3D systems, concrete, frame, hybrid models, wood, panels. Like, he's touched every material. He's collaborated with different companies of the sector, Pujol, Menpe, Arkinson, West. His studio is leading in applying protocols and seals as BRIM, Passive House, and others. He's also worked on health and architecture with WELL certifications and LEBC. Has a long experience in collaborative experience in planning, to planner system, and other more complex systems with complicated acronyms that maybe he can tell us about himself. So just to open your presentation, what made you suggest this solution for this three-dimensional for this plot? After so many 2D solutions, why did you opt for a 3D solution? Hello, good morning. Thank you to the organizers of the event to add CO2 zero emissions, at least in terms of heating. And maybe next time you can put some blankets on the chair because we're all freezing cold. I'm explaining the Marroc Street project today, as Cecilia said. This is done in Compacabi. And I will tell you about our way we chose R3D against other systems. But before I do that, as Japanese say, speaking of Kaizen philosophy, I would like to speak about other things we're working on. This is environment and deadline terms. These are the two main. And maybe for next year, I would like to launch a hint in the direction of environment, because I would like to show you images that are very sad, but they are real. They are fruit of the activity that the human being has on this planet. We are generating these cemeteries of waste, and we are one more agent. The agent of construction, we are one more agent to be generating all this waste, all these residues, all this waste. For a proposal of improvement in terms of deadlines, one of the acronyms Cecilia was mentioning is IPD. This bidding is already being done, and this has been a great advance. This allows us to reduce our deadlines in a spectacular way. And there is a collaborative work with the promoters, architects, construction specialists. The integrated project delivery, which is what IPD stands for, is offering solutions to this ecosystem of people participating in the development of a project. It's not just a construction company and some architects. There are so many departments, people, companies. All of these that we see on the screen have participated in this specific project. And we must be aware that just managing them over 60 people has to be done well, and this is essential. And it's essential to do it in an efficient way so that projects will be more valuable and agile. Can we say valuable? Well, in any case, proposals, working with IPD in a collaborative way, applying lean and 5S technologies. The automotion industry is one example of it. Today, the way we're doing is we're optimizing deadlines thanks to working with these industrialized standards with a reduction of over 40% of deadlines in the project and works. I'm going to tell you a little bit about the project. I'm not here to talk about my book, but just a little bit maybe. The reason why started here, reason why 3D. We're talking about Peraquart Street, which is near here, Rambla El Prim, in an 22 district, 22, where the industrial activity has always been very strong. We wanted to give homage to this neighborhood, and we wanted to construct a building that would give us an idea of 2.0, 3.0, 4.0 industrial activity, but in a newer way. When developing the project, we realized that housing modules were being developed, thought with 2 bedrooms each. And the first project was displaying a vertical communication axis and some stepping stones. But the first architectural project was leading us to very clear repetition, different pieces. And the architectural proposal was asking us to bring this to the 3D experience. How will we do it? Because we haven't started. When we start with the construction, the idea is to start with the central core and build upward through these 3D models and the stepping stones, which will allow phase 2 and phase 3 to be done in a more agile and dynamic way without needing some auxiliary intermediates and making use of this central axis to connect to phase 2 and phase 3. It is important to bear in mind that when working for a bit, apparently, apart from the fact that we have to be working really quickly, we are entering into identical designing. But then you realize that the first floor is not the same as second floor, and we can come up to 10 different typologies, which means that prefabricated industrialized systems should be capable of also work in a tailor-made way so that we can observe the different variations for each space or each floor. Regarding the different rooms, all the floors look the same. However, the way the water nucleus have been distributed are generating a triangulation, which, when it is juxtaposed to the gallery which we have in the stepping stones connecting to the passage gallery, are generated, giving an answer to a very broad answer in terms of how they're used. The different use typologies for families in the 21st century, ways of working from home, like home office, etc. Prefabrication and industrialization are 2 similar concepts, but they're not the same. When we are designing in an industrialized way, it is important to bear in mind how this will be executed also from the design stage. We can't give an answer to typologic problems later and ask the industrialization company to give an answer to those problems. We have realized how 2D systems were not feasible and compatible with our project, for example. It was a project that was thought to be carried out in a 3-dimensional way. Concerning the prefabrication and industrialization, the great difference between the two is that in prefabrication we're working outside, so the subsystem and components industry are elaborated in this way, in a controlled way, whereas in industrialization, goods and services are produced in the big scale with another technological component. Other examples being developed today are working more in a prefabrication way, not so much in an industrialized way. They are not, however, antagonical concepts, but complementary concepts. Before continuing on with this, I would like to give you a hint on our background. When I did a DAFOM, I thought it was the best thing in the world, but then I realized that after this health pandemic we've lived, and the crisis of raw materials, and a geopolitical crisis with the war in the Ukraine, which means that the production of materials is highly complex, and in our case we've suffered from these variations until we've reached a solution with Constructora de Aro and Compacabit. This is an image of the space where 3D models are being manufactured, and these are the 3D modules made in concrete. But as Cecilia was saying, this is allowing us to speed up our task. We can do the underground and the foundation part, as well as at the same time we're producing some components and systems in the workshop, and they can be added on to the structure as if they were kits in a much more efficient way, which is done in a very thorough quality control, allowing us to deliver 100% or at least 98% finished work. To sum up the virtues of 3D, it enables gender equality, because this is a highly genderized or masculine sector. In Group Pujol, they are saying they are proud that 100% of their such shutterers are women. Also, in terms of quality of finishings, this system allows a much higher quality. Also, an acoustic improvement of the environment, so we are not affecting the environment acoustically as much. We've asked citizens, would they prefer long works or shorter working sites, but with so hundreds and thousands of transports are also being eliminated from the city, because this is done in the periphery. Modules, obviously, that can be dismantled and used and recycled. It won't be our case, but in most of the cases, and if I had more time, I would explain how this works to you, but most of these models will have a second life. We can also overlap the on-site and off-site work in such a way that while we are working on the site and doing the foundations, we can also be working on the 3D models simultaneously. Before I started studying at university, I knew that you cannot build a fourth floor if you haven't built your third floor, right? Well, you don't even need to study at all to understand that. But I do know that when you are in a plant and you're coming up with 3D models, you can start using 2D models for the second and third floor, and when you're finished the third floor, you can continue doing that on the fourth floor, but whenever the space allows. But that will allow us to be working simultaneously on the third and fourth floor, which will speed up the process significantly, and which will mean more economical efficiency, less costs, reducing costs. And the great virtue of prefabrication also is increasing productivity through a non-controlled, through a controlled environment and different shifts. Working in shifts is also a big system. And this results in a great reliability regarding the systems, as Denzel Washington said, and I admire him as an actor as well as a person. It is not easy. Life is not easy. Not easy to do this in the environment of a pandemic, and it will not be easy to change a system along the way. It's not easy to give answer to all of these things. But every morning I wake up with the will and with the hope that this will be a reality. But if we don't hope for it, it will never be a reality. Thank you very much.
Okay, so after hearing of this successful project, and I say it's successful because despite all of the difficulties, we're moving forward with it. And I think you're right. I think you're right. So now we'll go on to hearing from some different experiences of modular industrialized production. In this case, it's another series of tenders for housing units. In this case, we thought we'd have Irene with us to introduce the APROP system. She isn't, so I will quickly go over the most distinctive features of this project, and the architects will then go on to explain each of the projects. In this case, the City Council Department for Social Rights, and to quickly and swiftly respond to the issue of a lack of housing, put out to tender the drafting of projects and the construction of housing units jointly. But in this case, the system was predetermined. It was a system using recycled shipping containers with high circularity and with savings in the delivery times. We did this way because previous studies had been carried out determining that this system was ideal for these units, and we put out this tender with the teams that later on developed the executive project and conduction of the works. So we have, of these two APROP projects, which APROP is a Catalan acronym meaning Provisional Proximity Housing. It's the Catalan acronym APROP. We have two which have been completed. The first in Ciutat Vella, and Yaiza Terreno will be telling us of that project, which was completed in 2019 with 12 housing units. And in fact, there are already people living in these housing units, and the feedback is also very interesting. It has a strong social component. And the second project is that near Glorias, which was, the works were completed this year, quite recently, but there are still no tenants living in those units. So I'll now give the floor, or I'll explain the project of Ciutat Vella. Yaiza Terreno with Euli Arquitectura and Travel were the drafting team and directed the construction, with Constelia and Eurocatalan as constructors. It's on numbers 8 to 10 of Carrera Nou de San Francesc, and as I said, it's 12 housing units. Yaiza is an architect. She has her own architecture studio for the recovery of heritage sites for cultural uses, and also housing projects with a strong social commitment and social such as APROP or cessation of use. She's working on a project with 72 housing units with industrialized construction using wood in the neighborhood of San Andreu. And My question to kick off your explanation, Yaiza, would be the following. During this first APROP project, it was in a very complex location in the old town of Barcelona, Ciutat Bella, where there's a strong gentrification, high density of population. We know the repercussion in the media was high. So I was wondering how you managed all of these social components. And I would also like you to answer a second question that is related to the first, in the sense that this system uses shipping containers, so it's an open universal system. And in terms of the project, what were the implications of this, working with solutions that are universal and that must be compatible? So, Yaiza, the floor is yours. Thank you so much. Okay, good morning, everyone. I'll stay where I am. So let's see. Okay, so maybe I need to go back. Anyway, as Cecilia was saying, I am here representing the 3 teams behind this project, APROP Ciutat Bella, with Straddle 3 and Eulia Arquitectura. We don't have the person who is going to tell us about the social aspects. That was going to be done by Irene Subils. But in any case, APROP Ciutat Bella, together with the other temporary housing, with the issue of the lack of housing that we see in many places in the world, it also happens here in Barcelona. And this project is especially relevant because it's a pioneering project. It's the first that was built in Spain using recycled shipping containers and in the old town of Barcelona, which is a space that can't really grow because it's densely built up and there aren't many spaces where you can build new social housing without people having to leave their neighborhoods to more peripheral areas where maybe it's easier to build the stock of public housing. With regards to the initial questions you asked me before going into the project, you were asking me about gentrification. And since this was a pioneering project, it was in the limelight because of its relevance at a social level and also at a political level. This was a strong political push behind it. There was a great expectation, I'd say, and when the containers started to be assembled, I mean, there was a lot of upfront work in the workshop, but when the containers were starting to be lifted into the land, it took 3 days to fit the containers one on the other, and the image was like, you know, like just second or third hand recycled rusty shipping containers just dumped one on top of the other, and that gave place to a lot of criticism. There were a lot of repercussion in the media. I remember The Guardian saying they were packing poor people into a tin of sardines, or other media said it seemed as if they were extending the port facilities into the town centre, the city centre. What we did was to take it from a teaching perspective. We were looking at all of the process. I mean, the building has been completed and it has cladding on inside and out. So once it's completed, it looks as any other conventional building. So we had to say, you know, that from an old recycled container, you can turn it into a building with the same features as any other building. So yes, there was this first moment where there was this image of the rusty containers, which led to some controversy. But as the construction continued, then people were able to see that they weren't just left as old rusty containers. And then you had another question, right, on how the shipping containers are a universal system. And it's true, and it's important because, as you mentioned, it's not linked to any concrete or specific supplier. There are no patents. Anyone can buy a shipping container and convert it into housing or give it any other use. And in this concrete project, the constructor company we teamed up with was Constellia, which was a small construction company, so it didn't need a huge workshop infrastructure. Just with an empty plot of land, they customized the containers and then carried them to the actual plot of land where the building was being constructed. So the fact that these containers are accessible universally is very interesting, and also it's a system that can be used in other locations, such as the APROP project in Glorias and other upcoming projects. And when we go into the details, you'll be able to see this. But the containers are, in one point, you have the connection points for all of the utilities, and it's located in the same place in all APROP projects. So the containers of one site could be easily installed in a different site, or even these two projects, Glorias and APROP, if they were dismantled at any time, these containers could be used in other sites because they're made to coincide. So we had these predetermined connection points, which on the one hand could be seen as a limitation, but on the other hand, if we look at the positive side, it means they could be used in a different space or at a different location. So if we go into the details, this project is located in the Gothic quarter of Ciutat Bella, very close to the La Rambla. Below La Rambla, the bottom part of La Rambla, below the Plaza Real. It's a plot of land which is on a corner opposite a square. It's quite a small plot of land. You see the image here. Before, this plot of land was used as a square, and even after installing the containers, they don't take up the whole plot of land. And conceptually speaking, there's a ground floor with a series of metal pillars and beams, and 4 layers of shipping containers are placed on top. It's also important to say that the containers are self-fitted. They can be used for maritime shipping, so they are usually faced with bad weather, they're moving, so when you use them for building, you don't have to worry too much about weather. And the system that is used to pile them one on the other is the same that you use at a dock in a harbour. There is a lock, a noose lock, which is the same one used everywhere when they're piled on a cargo ship. They are connected to one another, and then when they are all assembled, then we build the stairwells, the facades, and the rooftop. Here you can see a cross-section of the ground floor, the housing unit, and the rooftop. The ground floor is a space that has linked to a primary healthcare center in the neighborhood. The ground floor, as I was saying, it's a structure of pillars and beams that support the containers. It's an open plan which leads to a space in the corner that can be used as an extension to the square, and then there is a covered patio for the neighbors to move into the stairwell and go up to the housing units. And in the floor plan of the housing unit, you see the containers are placed longitudinally. There are 4 floors on each in this building, and there are 2 that make up a simple housing unit and two that are placed vertically, which can form a double unit with two houses. There are complications because containers are just over 2 meters wide and 11 meters 70 long. So obviously it comes with obvious limitations as for the housing unit size, but when you join them you can build housing units with a surface area of a small house. The smaller ones are around 30 square meters. The ones with 2 bedrooms are around 60 square meters. And the rooms are more generous with a kitchen with 2 kitchen tops, accessible bathroom that is accessible for wheelchairs, 2 bedrooms. And in future projects you could unite up to 3 or 4 containers. So it's a system that, in spite of the limitation, can offer many different possibilities. And the points where containers are used, they need to be reinforced. So they're self-standing, but where the containers are united, you need a frame that will, at the junction point, and we've thought this system was very valid, and, to build 4 up to 7 stories of containers with a low cost and without having to reinforcing the actual containers. And you could actually pile more layers of containers, but then you would need some form of reinforcement. So here we look at the facades. This is just to explain that Ciutat Bella, the limitation with the size and shape of the containers means that buildings are quite narrow in this Ciutat Bella. The neighborhood, the town planning and the size meant we needed 2 layers of cladding on the containers so that it aligned to the facades of neighboring buildings, and to give it a slightly prettier facade, which on the one hand to make the project unique and distinct, but the other reason for this double layer of cladding is to integrate it with these balconies that may remind us of the traditional vertical balconies in the Ciutat Bella, with these shutters, with the metal railing. The side facade is open, it gives onto the square and it's facing south, so we wanted to leave open spaces to make the most of the sunlight since it's facing south. And well, these are the construction details, just to explain that the container gives the structure of the surface, and then when it comes to protection from fire, sound insulation and thermal insulation, the containers are led with wood and different materials to isolate it. The container is just the structure, we could say. And then, as I also said before, when you want to merge 2 containers, you have to cut them open wherever you want to join them and reinforce the points of union. And a container, the front of it has 2 doors and the back of it has a back, and you have to replace the doors by wooden structure of the same size. As for the balconies and the passageways in the back, they are part of the container, and all of the elements on the facade and the rooftop are dry. All of the building was put in place in 4 months, with the 4-month work ahead in the workshop, and it's all dry so that we can relocate them if necessary. So we're trying to shift our mindset and think of architects and construction companies and all stakeholders so that we stop thinking of, I mean, the end of the day isn't when the building is inaugurated, but we think of its lifespan and the possibility of dismantling a whole building in its current location, and it can be carried to another location, and it could be dismantled and its materials could be reused. So it's not just about constructing the building, but looking at a second life cycle it may have later on in the day. And now I wanted to show you some pictures so that you saw the construction process. The first part done in the workshop. You can do it in an empty plot of land. Obviously, if the construction company has a workshop, well, then you can control the weather conditions better and you can have a better control of the delivery times. But in this case, it was done on an empty plot of land, and we did work on the containers. So we had the 4 levels aligned on the land, and when we were carrying out the executive project and looking at how to overlap the different stages to shorten the delivery times, meanwhile the construction company on site was working on the interior of the containers. Here they're installing underfloor heating, then there are these vertical patios, and when on site the different cables and drains and everything are put inside, and as I said before, they're all located in the same point of the container. So here you see what one floor of the building would look like with these 4 containers side by side. And at the same time, while this work is ongoing in the workshop, on site we did the first initial steps on the land to move earth and to lay the foundations. It's in Ciutat Bella, which has a lot of remains. Then we started erecting the metallic structure for the ground floor, and here the transport. It's also important to say that you'd use the same type of lorry that you use to move a traditional shipping container. The container can go on the same lorry, so it means you can optimize and use a resource that already exists. This was the initial moment when there was all this expectation when the containers arrived on site. So the first floor, and then how they were stacked one on top of the other. So yes, you see this image which generated a big discussion because, well, you can see these old shipping containers stacked one on top of the other, but obviously this doesn't show the picture of the end result. And this is the lock that is used to stack the containers. So these are self-standing containers stacked one on top of the other. Here we're installing the staircases. It's all produced up front in a workshop and then installed, then the rooftop, which is dry, and here we have the insulation, the outer insulation, and then the aluminum skin that was put on the facade. And here we can see pictures of the finalized project, which obviously is quite different from those initial images when you just saw the raw containers. Once it's completed, you see the facade with aluminium layers which melt in well with the old town of Barcelona. Here we have a picture of the access area to the containers, the staircase, and this outer layer which is where the balconies are. And we have 2 images from the inside of the single unit and the double unit. Obviously, in the double unit, it's wider. And here we see the list of collaborators, as Marc and Cecilia were saying. This is an extremely collaborative project. It's all done at the same time. Conveying the information isn't a top bottom going from the architects to the construction company to the workers on site. It's horizontal. Since it was a pioneering project, it was the first time we built with maritime containers, so we had to carry out research while the project was being drafted with all of the stakeholders involved, including firefighters who'd never seen this type of construction. We had to look at how they're going to be carried, the Energy Agency of Catalonia, social services. We held quite intense weekly meetings to look at how we could get these containers to be turned into a building, because we hadn't had previous examples. And that would take me to the end of my presentation. Thank you. Thank you so much. Yaiza? Great. Okay, so we'll give the floor to Lluís. We're running slightly late, I think, time-wise. We started a bit later. So, Lluís, let's try keeping it short. Let me introduce you quickly and then you can explain. Lluís will tell us about the second APROP project together with Javier Ramos. They are the co-authors of the project and supervise the works together with the Calaf construction firm. It's 42 housing units on Bolivia Street in the area near the Plaza de los Glorias, which means a totally different location compared to the first, and it's at a totally different scale also, because it's not applying the project in the same place. He was the executive director of the Tribuna Arquitectura studio, and he's worked in many projects: housing, facilities, urban planning, refurbishment. He has a broad experience in industrialized construction. He's worked with 2D, with concrete pre-formed slabs, also CLT, wood and steel, and also prefabricated modules, or the more recent project they worked in Poblano. So I wanted to ask you, Lluís, since this is a second experience, would you say you were able to see a technical evolution, or were there any lessons you were able to learn from the first APROP project? Also, could you tell us during the line how this collaboration worked? The floor is yours. Thank you. If you don't mind, I'll walk up here. Okay, so hello everyone. I'm Lluís Ramos, as Cecilia said, and I'm here representing another architect called Javier Ramos, who is also here in the room, but I'll be giving the presentation. So, with regards to your questions as to the lessons we've learned from seeing another building built with shipping containers, well, you can always learn positive things, because you can see how a project can be delivered, you can take conclusions, and you can also see those points where maybe there were some difficulties or challenges to overcome them. I remember one positive learning from Yaiza's project was to think that the staircase modules could be prefabricated. Before, we saw a slide where we could see how these staircases were made in stretches in a workshop, and then they were just installed. In our case, all of the upfront studies that were carried out by the city council, for fire protection, I think that when Yaiza started the construction of the project, they hadn't fully overcome the issue of fire protection. We were able to study this, and we were able to reduce the 3 layers of plaster, cardboard, and narrow it down to 2 to give it greater protection from fire and to simplify the process. And Cecilia, you mentioned the benefits of these projects, the APROP projects. Besides efficiency, the other important thing is the sense of urgency. We needed to be able to complete the construction rapidly, and you can do this using collaborative processes such as contracting the project and the works at the same time simultaneously, and this responds to your question. This collaborative project, which was done by Constructora Calaf, meant that when the project and the construction were contracted at the same time, you only need to participate in one bidding process for the tender. And it means that working together with the technical team and the construction team, you can achieve much better coordination between the works and the development project, and it reduces many of the unforeseen events. So in this case, the timeline was 3 months for drafting the project and 6 months and a half for the construction. And just to recall what Yaiza was saying before, and Marc also said this, you can work on the containers in a workshop, and at the same time you can start construction work on site, like laying the foundations, moving earth around, or even, as Yaiza said, you can start to work on the containers because you know where you need the vertical pipelines for the cables and sewers, so the construction company can start doing all of this work in the workshop up front. Another advantage that made things easier for us compared to Yaiza's project was the location. As you said, it's in the area of the Plaza Las Glorias. It was a plot of land where the width of the adjacent streets and the urban planning meant that it was ideal to carry and load and unload the containers, so it made work easier for us. Let's remember that these containers, and you will be able to see this better in the next slides, it's a project with 11 containers per floor, which means 6 housing units per floor, a total of 7 floors vertically up. So here we've reached the maximum capacity of these containers without having to reinforce the structure. They are self-standing. We've taken them to the max. And these 11 containers could be assembled in one day. And the following day, you could move up one level. So in 2 days, we had 2 floors executed. Then we had to wait 15 days to bring more containers on site. By this, I mean that the location in this case, I think, met the ideal conditions for this type of constructions. So for this facility on the ground floor, it has spaces to accompany the residents. There's a laundrette and there are multiple use rooms. In the interior patio, there's space for those living in these housing units to be able to meet and talk. And there's also a large hydroponic vegetable garden that will be managed by the Municipal Institute of People Living with Disabilities. There are 7 floors, 6 housing units per level, which are accessible through internal corridors facing south, which at the same time are used as terraces for each of these housing units, and they also can be used as spaces for neighbors to interact. On the rooftop, we have all of the centralized services, and it's been all of the rooftop surface has solar panels on it. As I said, each floor has 11 containers. There are 2 types of housing units, one made with 1 container and then others made up of 2 containers, which, as Yaiza said, you have to open the sides of the containers to connect one container to another. So here we see the 6 housing units per floor. So we have some with 1 bedroom, others with 2 bedrooms. The constructive system we used was recycled shipping containers. This industrialized system allows us to improve efficiency because, first of all, we're using universal elements, which, as we said before, anyone can manipulate. You don't need large infrastructures, and it can be done in an easy way. Secondly, also because they're easy to carry and assemble. We have the 40-foot iCube model. We saw Yaiza's slide where you have the lorries that are made to carry these containers. Thirdly, also it shortens the delivery times for all of the points we mentioned before, and also because the modules are self-standing and don't need reinforcement structures. In this case, having a plot of land where the front line was 14 meters allowed us to open the module at the back and the front, and leaving these access ways that are 2 meters wide. It would allow us reach to the distance we were allowed by law, that is 14 meters, and this allowed us to provide for natural lighting and ventilation. We have a facade which is 12 meters deep, and also in this case we adopted central aerothermia. We didn't use underfloor heating at the end. It all works by air conduits, but if you combine aerothermia with solar panels, this is an excellent solution energetically speaking, and that is the solution that was chosen. There is also an optimization of the space. Each square meter has a functional use, and at the same time we use easy, low maintenance and highly resistant materials. Thinking also of what you said, Yaiza, that the life cycle of this container isn't limited to one single building. They can, since we had some guidelines to make these containers compatible with other similar projects, as Yaiza said before, they are totally compatible with setting them up in a different location.
Concerning sustainability, this is also something that is taken for granted in this kind of project. It is a sustainable construction because it involves a reduction of the environmental impact, because it's mechanizing and optimizing the reduction of waste using recyclable and recycled material. In terms of temperature regulation, we have photovoltaic and hydrothermal. We're using rainwater and storing it underground, and clothes washing is centralized in order to minimize costs and space in these locations. All these actions makes the energetic classification of the building is rated as all double A. The ground floor, as I was saying before, has a central space for management where the offices for the management of the equipment is. Then there's a poly-use multifunctional space, multifunction room, and there are 2 elevators because there are more than 24 housing, and there's a space that is undefined here. There's a prototype floor, which is the same for every floor, and the only thing that changes is the position of the balconies. In the beginning, we studied the option for every container having its own balcony, but in the end we opted for an option where they were distributed in a zigzag distribution, where budget was able to be we were able to keep to the budget, and therefore the balconies were reduced to 50%. There's a container next to the elevators, and the rest are two lodgings. There's a functional program of one or two housings, and it changes in the sense that the living room, dining room is bigger in the two container one, but when it kitchen and bathroom are bigger as well, and they have a second bedroom. That's the different from the one container housings. The roof is full of photovoltaic plants, and this is the facade looking out on the main street. All these solar panels are filling the roof. The roof is totally filled with solar panels. The facade is covered and cladded in a sheet metal, but we have wanted to show that this has been done with shipping containers. And the original container doors have been kept. They have been maintained. This would be the inner facade looking out onto the inner patio, reflecting the modules, which are powerfully conveyed by the containers, but they are looking more like a southern patio, giving it a different aspect, a different look. Differently from what my colleagues were explaining before, our project was working on the container, and there was some retouching that was necessary because of stagnancy issues, thermal protection, etc., which meant that some elements on the facade have to be placed in the last minute. In my understanding, the evolution of such projects should have to do also with the fact that all of these elements should be able to be implemented from the start. In our case, the joining of the containers, which structurally were using the standard pieces for such end, twist lock and bridge lock, horizontally and vertically joining and fixing these containers ones with the other, such as they are fixed when they are being shipped in by sea. So vertical sheet metals and horizontal sheet metals were manufactured, which allowed the isolation to be put into place, and they were indicating the place where each square was a container. So they were indicating where each container started and ended. In terms of the containers, they were totally prefabricated. They had been manufactured in the workshop, and the only thing that had to be done was to regulate them. That was the last action that was carried out on the level of the facade, the sheet metal and the balconies. And this would be the image of the end result of the facade with all the side doors and the alternance of the balconies, the inner patio, and the inner courtyard. And something interesting in this project as well, which was more regular and which allowed us to work with these container pillars in a much better way was this passage which allowed us to distribute the facilities. We had a vertical nucleus or center, this hole next to the elevators, and this is where this passage would distribute the different equipments, always thinking about the potential dismantling. It's important to bear in mind that this passage was necessary for the equipment. These reinforcements were necessary in the simple module. They were simpler because the openings were smaller, but these reinforcements should be executed when doors or the container background are dismantled. So there have to be some reinforcements. And in this case, we did them in tabular formats. What is more complex are the side openings, which had to be done in order to connect the two containers. So a two-container housing unit had to involve these two openings. This structural diagram had to be done thinking about the wind. The passages had an additional structure that one you see on the screen, and here's a video to show you about the goodness of this procedure that allowed this to be done in a workshop, in a controlled environment, working in different shifts. The construction company is working in Calaf. In the wintertime, it's cold. In the summertime, it's hot. But there is an environment that allows you to work here and without being affected by the big differences in temperature. Here's the concrete on which the reinforced concrete on which the containers are to be placed, and then the passages were on ladders, and the communication center that is used by the workers in order to work at the construction site. And this has to do with what Marc was saying before. Here are some images of this working phase in terms of the structure of this interior passage. With a first floor of containers that has already been assembled. This is one of the floors, I can't remember which, but these are the roofs of the containers themselves. On top of them, the next layer of containers are placed. When you step on those containers, they wobble a little. They're not really thought for bearing a lot of weight or for walking on them. In the Ciutat Vella district in Barcelona, the degree of industrialization in this construction was higher because the outer passages had been also done in prefabricated panels, but here the steel was different. And this is the image here's the interior the inner courtyard. It makes it a bit harder to understand that this has been made up by containers. But here we see to what degree details are being defined and how it is contrasting with the neighboring buildings and the different phases of how the building was growing. And upward. Here's the moment where the metal sheets were started to be placed, and here's the rooftop with the solar panels, and finally the inner final space, a vegetable garden. So this is all. Thank you very much.
Bé, doncs ens hem menjat. Crec
I think we ran out of time. So after looking at these three different projects, we can now give way to the next panel. Thank you very much for your proposals.